Okay, in this video, we are going to discuss about stationary waves. And stationary waves are basically is related to interference phenomenon of waves, in which we will have to say when two waves of same frequency, of equal frequency or same frequency, and and amplitude are traveling in opposite direction, are traveling in opposite direction, then they produce stationary waves over there. For example, we say here the two waves which we should take. For example, here I am showing to you. This is the medium, like in the form of string over there. This is the support which you are provided with. And what happens? You provide a jerk from this side. What is happening? The string starts to oscillate like in this pattern. Then what will happen when it strikes with the support medium? It starts to move in backward direction by placing its zero amplitude points at the same point and reaching exactly towards your hand in this format. And the points where the amplitudes are zero, with the help of highlighted points here, are named as nodes, and the points at their maximum amplitude peaks over there are named as anti-nodes over there. And in this way, we say nodes are stationary points which are remaining at rest over there. On the other end, antinodes are oscillating points, are vibrating points over there. Oscillating points over there. And when we look towards its structure of propagation over there, and how we differentiate them from the main basic waves over there. If I say red one is going in the form of one direction, then the other direction can be given as, like, red is going in this direction, in this direction, in this direction, then green is coming back in this direction. And both waves of the same frequency, same amplitude are oscillating in opposite direction. Then we say these are the stationary waves. If I compare them with the normal progressive waves and stationary waves, progressive waves with the normal waves, in the previous lecture we have discussed about the waves, about their amplitude, their wavelength, and today we are going towards stationary waves. What is the difference between them? Basically, we will say progressive waves are basically using the transferring the energy, like they transfer, net transfer of energy is available, like energy is transferred from one point to another point without transferring matter over there. Net transfer of energy is present in this case, while in stationary phase there is no net energy transfer. No net energy transfer is available in this case. Wait a second, I want to change the color of this pen. It is not highlighting properly. Okay. No net energy transfer in stationary waves over there. And if we look towards the progressive waves, their waveforms to be translating. Their waveforms show like translating. Like they are moving from one point to another over there. And on the other end, its waveform is going to appear as stationary over there, like the waves appear to be stationary. Waveforms appear to be stationary. Means they are not leaving their positions and they are settling down at their points of nodes and antinodes over there, and they are not going to appear as they are moving from one point to another to transfer energy over there. And in the case of progressive waves, we say that each point has the same amplitude and the amplitude of wave, like that. Here we say the waves have same amplitude as the wave will have. But in this end, we say some points have different amplitude, which is the result of superposition over there. Principle of superposition is going to hold over there. Like each point has different amplitude because of superposition. Principle of superposition is going to hold, which is defined as the amplitude at any point in stationary force or in any wave is the algebraic sum of all the sums, all the waves at that point. That is called principle of superposition is going to hold in case of this is stationary waves over there. On the other hand, here in progressive waves, we say there are crests or troughs are available as the peak values in transverse waves over there. And if they are going towards longitudinal waves, then we say there are compressions and maybe the rarefactions are there. So both of these cases being taken into account for progressive waves over there. On the other end, we will say here they have nodes which are stationary, means no vibration is available for those points over there. They are at zero amplitude, like x is equal to zero as a displacement over there. And antinodes are available, which are oscillating points and properly showing its displacement equal to exactly as its amplitude over there. And these are called constructive and destructive interference doing waves over there. So whenever we are observing these types of waves, then we are saying how they are going to be taking as phase difference of node and antinode should be taken into account. For example, I am taking here a waveform uh, which is initially present here as a waveform of oscillation stationary over there. Then I am saying this is, for example, this is my initial wave at the point this with its x-axis and y-axis over there. This is my wave which is acting along y-axis. This is my x dash axis over there, and it is my y and y dash axis are available over there. And let's suppose I am taking some points on this wave to explain some behavior of phase, out of phase and in phase. I'm taking some points at this wave. I'm taking X, I'm taking Y, then I'm taking a peak point as F over there. I'm also taking here C and B points over there. And C I'm taking a little bit up, and B is also I'm taking in front of it. This is my B, this is my C over there. And in the below where I am saying here, it is my D and E point. And on the other end, I am saying here is my I and here is my H point. So when I am taking the stationary waves according to their node and antinodes over there, this is my node, this is my antinode, this is my node, this is my antinode, node, antinode, node, antinode can be shown on the x-axis line over there as the medium line, like the string when it is having no stationary wave over there. Then if you observe here x and y or you are observing here CB, or CB, X, Y, and F, all of these are the upper peak over there, and they all are in phase with one another. When I am saying here like X, Y, and like what I'm saying here, point X, point Y, point F, C, B, F, C, and B over there, all these points which are at the upper peak over there, they all are in phase. All are in phase. Means they are reinforced with each other. They are not canceling their effects over there. So any 2 points between adjacent nodes are in phase. Means this is the node, this is the node. Any point between the node are all in phase. On the other end, when I take the lower one, like as I said here, while I'm taking D, E, H, and I, they are also between the two nodes when the points are being taken on the amplitude increasing displacement over there. They are all considered in stationary phase, like stationary waves, that their phase difference delta phi is always equal to 0 degree when the points are lying between adjacent nodes they are. And if the points are lying left or right of the node, for example, I take here another points which are lying in opposite difference of node over there. Like we can say here, if I say I'm taking one Y and then I'm taking one D over there, or one C and one H I am taking over there, then I will say here phase difference between YD or phase difference between CH, or I am taking the phase difference in case of, I will say, BI, then what it will happen, BI over there, then I will say they are out of phase. Out of phase, having phase angle of 180 degree is the phase difference in case of stationary waves over there. After that, after explaining to the phase difference, now I am moving towards the time period of a wave over there, of a stationary wave. Let's suppose I say I am taking here man 4 figures to be drawn over there. Oh, for showing its time period with 1/4, then 1/2, then 3/4 as its time period. And then in the last, I am saying I am taking as T complete. When I am saying that, let's suppose the maximum amplitude of the wave is shown over there in the form of this, 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 and this is shown. When initially I am starting my time period over there, let's suppose I say it is being shown by its value to complete one more cycle I'm adding here, like in this form. Let's check now how it is happening. When I'm saying it is when t is equal to 0, after time t, what will happen? That it will have its node, antinode, this is node, antinode, node, antinode, node, antinode, node, node, antinode, node, antinode. After that, node, antinode, again, node, antinode. After that, node, antinode, node, antinode is shown on there. And the last one is again node over there is being shown over there. So node, antinode, node, antinode, node, antinode, node, antinode, and node is shown for this complete graph. What is its having the 0 resultant over there means after for 25% time period passed away, then the result will be having the 0 magnitude over there after t half. Like when the node, if you are starting from the node to antinode, then it means the effect of this one is this wave has moved to the next, traveled to this point. So it means it has reached towards this point where node is touching. At the antinode, it is again being giving the cancelled out effect over there. So zero amplitude will be obtained over there. And after 1 second, what will happen, like when your time period is being shifted, then at time t is equal to 2 seconds. Here you have taken that your t is 0 second. Here you are saying t is equal to 1 second. And I am taking my time period as t is equal to 4 seconds for this wave over there. After 1 second, this will happen. After 2 seconds, it will be showing like this 50% is gone over there. And now I am starting it from this point. So my wave will be starting like this, this, like this form is going on when t is equal to 2 seconds. And this will again at t is equal to 3 seconds, means 75% of my time period is gone. Then the wave will be shown will again the zero amplitude over there. No node or antinode are being shown for this time period. Then I am saying that this is t is equal to 3 seconds, and means total time period is being done 75%. And again, when t is equal to 4 seconds, then it is coming to the original form back. So this is the way how the wave of stationary waves is showing its maximum amplitude over there. If I say this is maximum positive, if I say, even though it is inverted in the figure, I'm saying it is maximum positive, then it is showing 0, then it is showing negative maximum, and then it is showing again 0, and then again he is showing the maximum positive. So this oscillation of the time period is going on, maximum 0, negative maximum 0, again maximum. So one cycle of a stationary wave is going towards the completion of its value by having, we can say, first of all, it will, for example, starting with maximum, then it is going to 0, then again it is going to negative maximum, then again 0. So this is the way how the cycle is completely going on and working according to the requirement of the question over there. After that, reflection of wave, how it is going to be happened over there. For example, I said it should be taken. Wait a second, I'm coming back. Okay, now how the reflection of waves is coming in and out with the obstacle over there. Let's suppose I say reflection of waves is happening. A reflection of waves in stationary waves, when it is striking with a medium, it is reflecting back with the totally 100% like trough or crust reflection like that. When I will say here, for example, this is our support, and here you are going with the crust going to incident on this obstacle over there. And when it is coming back, this is the fixed end, which is, we say it is just like a support with which it will strike and will reflect back over there. Then what will I say
Sure.
here? That after reflection, what will happen? It will be coming back. If it is crust going to strike over there, then you are getting trough back going towards the back phenomenon over there. Then here, when it is called a reflection, which is out of phase from fixed end. It is out of phase with out of phase reflection from fixed end over there. But on the other end, if I say my crust is going and crust is coming back, like crust is going towards this fixed end, and on the other end, my crust, this is going in this direction, this was going in this direction, it was coming in back direction over there. Now, if I say this is my support, fixed end over there, and as a crust it is coming back also, then I will say reflection is in phase from free end over there. If the end is free, then it is coming back in the same pattern. This is called a free And when the wave crest is going and crest is coming back, then it is called in phase reflection, in phase. And when you say that it is your free end, or you are saying that this is your fixed end, then the reflection from the fixed end will be in the form of out of phase. And if it is free end means it is not going to reflect back with the out of phase different. It is coming back with its the same crest, same trough with which it has gone to strike with that medium over there. After that, the last section of the stationary waves, which we will have to consider over there, this is related to stationary waves between the both fixed and how the speed is going on, how the frequency is going to affect them. For example, let's say I say here, like you are having two ends fixed, and here you are provided with a string. At the center, what happens? You just hit it with your finger. It starts to oscillate up and also to oscillate down. It means first harmonic has been built up. Let's suppose I say this is your whole length, and if we observe our wave, this is our complete wavelength. And if you are still stuck till here, then it means your wavelength is half. So length of wire, length of that string, which is L, then you will say lambda over 2 is equal to L over there. After that, this is your first harmonic. After that, second harmonic. Then I say you are plucking your finger almost in this way that you are getting one complete waveform with the two harmonics between the two ends over there. Here, your one wavelength is complete. Then you can say here that your lambda by 2 is now equal to lambda, which is equal to L over there. And we can say here it should be taken as V over L should be taken for the case when lambda is equal to L. And when I'm taking third harmonic again, this is my fixed end, this is my fixed end. I am producing it this, and I am producing is this. This is coming like this, and this, and three harmonics, even though their size should be same over there. And then I will say here, now my one length is going to take the lambda value as 3 lambda by 4. Means it is my 50%. It is my, what should I say? One complete, it should be 1.5. So it is 3 by 2. It should be 3 by 2. If I make a proper sequence over here, this is 1 lambda by 2. This is 2 lambda by 2. This is 3 lambda by 2. It means the increase in number to make a proper sequence, 1, 2, 3 harmonics is getting its increasing order from 1, 2, 3 from the numerator value over there. And if I want to calculate towards its wavelength over there, then I will say here my wavelength is V is equal to F lambda. If I want to go for the calculation of frequency from there, then I will say my lambda is 2L over there, and F is equal to V over 2L for first harmonic. After that, F is equal to, if 2L is again I'm taking, then it is 2 lambda over there. So 2L over 2. So I should go with V over L, like 2V over 2L. So I will say it is going with the V over L like that, but I am considering this one so that I can make my sequence 1, 2. After that, third one also will come. F is equal to V over lambda again. So V over this lambda, if I take 2L over 3, so 2L over 3 is coming with this numerator. So in general, my frequency of harmonics can be given as Fn is equal to Nv over 4 2L over there. So this is the way how to go for harmonics frequency in case of stationary waves should be taken into account. And The same case of the waves I can take when both ends of the pipe are open over there. When same calculation 100% will be done for it. For example, I'm taking a pipe and I'm saying its length is taken as L, and I'm saying it is at the both ends, it will have always the antinodes to be present over there, should be taken like this. So this is also equal to like 25%, 25% means 50%. So L is equal to lambda by 2 again. And when you are taking your one harmonic between these 2 points again, now it is going towards two harmonics to be produced in it. Then I'm saying it is going to behave like this, and also creating like this, also creating this, this, and this, and going to behave like this. Then L is equal to lambda there. And the third one case where we can say our wavelength is being taken, then we can say it is going towards adding two harmonics between them, like in this form, one in this form, one in this form, and at the end again the antinode is present. Then I will say here it is my length is equal to 3 by 2 lambda, 1.5 lambda is present over there, which should be taken into account for calculation of wavelength over there. And the same scenario, if I use V is equal to F lambda over there, and then I need frequency over there, then it is V over lambda. If I make for the first one lambda is equal to 2L, then I say F is equal to 2L, so V over 2L. And for second one, F will equal to 2V over 2L. For third one will equal to 3V over 2L. So our general formula will be NV over 2L, where N is equal to 1, 2, 3, up to so on. And the other section of when one end of the pipe is closed and one is open, what will happen if I take this is a pipe, getting its value to strike like this, getting its value to strike like this, and then I say it is only 25% of the wave to show the its complete wavelength. This complete wavelength is this. If you are getting only this part you are taking, this is called 25%. What I will say here, that my length of the pipe is equal to lambda by 4. If I say here that my wave is produced in this form, like one harmonic is complete, but the second harmonic is only showing the 25% over there, then I will say now it is my 0.75, means L is equal to 3 lambda by 4. After that, if I say here, two harmonics are shown, like in the form of this, in the form of this, and then ending is shown at the end over there. First harmonic and second harmonic are shown over there. Then I will say now it is 1.25. So it is 1.25. Then I will say L is equal to 5 lambda by 4 over there, according to its wavelength structure over this. Then we can say we should also go to consider that V is equal to F lambda. If I take and lambda is equal to 4L, so F is equal to V over lambda, which is equal to V over 4L. I have just used this lambda equal to 4L. After that, what is happening in the next case? This is for first harmonic. For second harmonic, he is showing towards lambda is equal to 4L by 3. Lambda is equal to 4L by 3. Lambda is equal to 4L by
यार
3.
लेकिन ये जो SHM वाला चैप्टर है ये A2 का नहीं है?
What happened?
ये SHM वाला जो चैप्टर है सिंपल हार्मोनिक मोशंस वाला, ये चैप्टर A2 का नहीं है?
We are not doing SHM, we are doing stationary waves.
सर ये हार्मोनिक मोशन जो कह रहे हैं आप,
No. Harmonics are just like these bubbles.
अच्छा
Okay, harmonic motion is separate thing. वो
जी
elastic body is being used to compress and relax over there. Okay, now he is saying V over lambda is 4L by 3. 4L over 3. So it is 3V over 4L. After that, for this one, it will become F3 will become equal to 5V over 4L. And from here, if I get my general formula, Fn is equal to NV over 4L. And remember that my N will equal to 1, 3, 5, 7 is the sequence to follow up these stationary waves over there. We will get this from MCQs questions also from this topic. We will have some short questions related to our structured question paper will also be included for this topic if he is taking the waves as the main question from stationary waves. This was your topic related to
जी
stationary waves. In the next class, I will try to complete the Doppler effect and Young's double slit experiment for tomorrow class. Can you have the class tonight?
जी
Musa, can you get class tonight?
किस टाइम सर
Like,
टाइम
uh, like, 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 like 10?
ठीक है
If I will be busy, then I will straightforward say sorry. But if I will try to manage the class, okay?
ठीक है सर
Thank you so much for today. And this video will be uploaded on YouTube if you want to check that.
ओ माय गॉड आई विल बी ऑन यूट्यूब
Yes?
यानी सर मैं थोड़े समय यूट्यूब पे आने वाला